Good afternoon. Welcome to today's broadcast of SCA's webinars with Dr. John Lee. John will be discussing the new PRMS regulations. And before we start today's webinar, we'd like to ask a few questions about the demographics of our audience. So I will be sharing some poll questions with you. The first question is, what is your primary discipline? So the polls are now open. Looks like we have quite a few petroleum engineers in the audience. A few in the other category, but I'd say the majority are petroleum engineers. Almost all of you have voted. So I'll go ahead and close that poll. It looks like we have 89% that are petroleum engineers, 11% other. So let me pull up the next poll, and this one is a bit more demographics. How many years of full-time experience do you have? And looks like these answers are more widespread. So we have a good group with 56% in the 1 to 10 year range, and a good spread over the different other demographics of experience, with 22% at over 30 years. So I'd like to remind our audience today that you are muted as the presentation starts, but you can ask questions throughout the presentation using the GoToWebinar question feature. And we will stop at the end of the presentation for a few minutes of Q&A. Your questions will be anonymous, so be sure to ask those questions as we go. And so I'd like to share a little bit of information about Dr. Lee. This is a webinar with an excerpt from one of his classes, and he's going to give us an update on the new PRMS regulations in 2018. And Dr. Lee is well known throughout industry, and he is the Rob L. Adams Professor in Petroleum Engineering at Texas A&M. He has 3 degrees in chemical engineering from Georgia Tech and started his career at ExxonMobil. He's been very involved in reserves and reserves characterization throughout his career. He worked at Holditch and Associates. He was a fellow with the SEC in Washington as they were modernizing the rules 10 years ago. He held the Cullen Distinguished University Chair at University of Houston for 4 years as they were launching their bachelor's program there. He's published 4 textbooks that are available through SPE, and he's received almost all the awards that SPE offers, including the Honorary Membership Award. He's a member of both the National Academy of Engineering of the United States and the Russian Academy of Natural Sciences. So the course that Dr. Lee teaches through SCA on PRMS and SEC Reserves and Resources Regulation is a 2-day course, and it's available for 3 different times in 2019, twice in Houston and once in Dallas. So look ahead to see which time and location works out best for you. And we can set these up either at your location or in the SCA training room here in Houston or in Dallas as necessary. And the next webinar that we're presenting is being offered by Dr. Bill Little, who is giving a webinar in November on the Book Cliffs field trip that he offers through SCA. And of course, in addition to training, SCA offers additional polling, additional consulting and services for staffing as you need it. And so next I'm going to hand the presentation rights over to Dr. Lee, and as he takes over presentation rights, I'll remind you to please post your questions throughout the webinar, and we will get to them at the end. Good afternoon, Dr. Lee.
Good afternoon, Susan, and thank you for your introduction. Good afternoon or morning, depending on where you are, for those attending. Let me make some mechanical adjustments as we get started. I'm going to talk with you today about the updated Petroleum Resources Management System. And this presentation, this presentation will be just a subset of a selected kind of topic from my two-day course that Susan mentioned. Before I tell you more about that, let me open with a disclaimer. And please note that there will be opinions in this presentation. Please understand they're mine. They don't necessarily represent the views of the SBE's Oil and Gas Reserves Committee, nor of any of the sponsors of the PRMS, which were identified on the earlier slide. Also want to make it clear that the material that I'm going to present today is very heavily based on publications and presentations by members of the PRMS update and drafting committees. If there turn out to be errors and omissions, they're solely my responsibility, and they should not be attributed to any of my source materials or authors. I do want to mention that the two authors that I've leaned on most heavily are John Etherington, who has prepared a nice, concise summary of the update to PRMS, and Dan DeLuzio, who chaired the updating committee. But I've selected materials from what they've done, and if they're not consistent with the views of these folks, then it's my fault. That's the bottom line. All right. In this presentation, of course, we're going to be talking about PRMS. I'm not going to show you how to apply PRMS to any particular resource evaluation. That will be a topic which is best covered in a much more lengthy presentation. Instead, I'm going to confine my comments to a look at some of the more important changes. And you really need to see the entire PRMS in a longer course to understand the context in which these changes have arisen. So with that understanding, we'll begin. And I think an important first question is, what are the objectives of PRMS? And the answer to that question is, PRMS is designed to support consistent petroleum resources evaluations based on technically sound practices. It's important to understand that it is not specifically designed for external reporting, and that includes regulatory disclosures. This is not a regulatory system. Instead, it's designed for technical and business requirements of oil and gas companies. Now, another objective is to meet the needs of government agencies and financial institutions and industry consultants. And PRMS can allow government agencies to develop their own reporting and disclosure requirements that meet their needs, but still PRMS is designed to maintain consistent practices by people in industry. Now, for those in the audience that are in the US, and typically this is almost all the audience on webinars like this, most US people have reasons to be much more interested in the SEC regulations than in the PRMS classification system. What's the difference, and why should an SEC filer also be interested in PRMS? Well, the SEC, it emphasizes relative comparability of companies that disclose proved reserves. And notice the emphasis on proved reserves. Few SEC filers file anything other than proved reserves, and the SEC does not allow disclosure of resources other than reserves. Now, in the proved reserves area, each filer has to use the same basis for prices and costs, namely current constant prices unescalated with time, to the extent that discount rates are referred to. They have to be the same. And the SEC in particular requires that projects mature, that is, be implemented within 5 years with rare exceptions. By contrast, PRMS is geared toward providing a consistent set of standards that can be used to estimate, classify, and categorize a company's petroleum resources. And notice I said resources, not reserves, prospective and contingent resources, along with reserves, in an absolute manner in an attempt to capture the true value of developed reserves and the true growth potential of undeveloped projects. So we might ask, who has adopted PRMS to date? And I've listed on this slide regulators, financial groups, and government reporting agencies who, along with individual oil and gas companies, have adopted PRMS in some way. At least PRMS is either implicitly or explicitly referenced by these different groups. For example, in the US, the SEC is the regulator, and the SEC has its definitions that it uses for resources and reserves, but the SEC has different definitions in some cases and different guidelines in some cases from PRMS, but still the SEC, the modernized version of its definitions and reporting requirements, still has strong roots in PRMS. Other regulators have even stronger roots. And as you browse through the list, you can see that PRMS is truly an international standard. I think the next question that we might be interested in is, who developed the updated PRMS? And in fact, why was there a need to update PRMS at all? Well, the who. The effort was led by the SPE's Oil and Gas Reserves Committee, or ORGC. But in addition to the members of ORGC, who are members of SPE, this was also supported by representatives of several professional societies, which are identified in my next bullet. The update committee was dominated by SPE members, but it included representatives from the other professional societies who regularly contributed and who kept their boards of directors updated on the progress in this effort. These societies beyond SPE included AAPG, the World Petroleum Council, SPEE, the Society of Petroleum Evaluation Engineers, SEG, the Society of Petrophysicists and Well Log Analysts, SPWLA, and the European Association of geologists and engineers. And the sponsors had agreed, and this is getting into the reasons for the update, in the original version of PRMS, which was issued in 2007, the agreement was to keep PRMS evergreen. Now, in the 11 years that have elapsed since the original PRMS, there have been significant developments in technology. There have been significant changes in focus areas by many of the users of PRMS. This is particularly true in the area of unconventional resources, which were becoming important, but not nearly as dominant 11 years ago, or really more than that, because PRMS was actually developed originally over a period of several years. Unconventional resources are much more dominant now. Another reason for updating is that even though the authors of the original PRMS did their best to make PRMS clear, given changes in focus, etc., it was pretty clear in later years that even though there's no necessarily a change in many of the definitions and guidelines, there still was a need for clarification. So I'm going to talk with you today about the major principles of PRMS to provide some context, and then I'm going to move into some of the areas of major change. My look with you at the major changes is not by any means going to be exhaustive. I'd rather cover a few things reasonably clearly than try to give you a long laundry list of all the changes, with the risk there being of considerably less clarity in the overall result. So let's start with the major principles which were retained from 2007. First, I'll note that PRMS was and remains a project-based system. It bases classification of a resource on a project's chance of ultimately becoming commercial. It bases categorization of resources within a given classification on the uncertainty of recovery. It uses the resources evaluator's forecast of future conditions in a base case. So they're not fixed, constant conditions as in SEC, but the evaluator's forecast of what the conditions will be over the duration of the project. PRMS did and still provides granularity for project management. It allows either deterministic or probabilistic estimation methods for categorizing resources in a given classification. It applies to both conventional and unconventional resources, intended to do that from the start, still does, but as I've indicated earlier, with more clarity on some important practices for unconventionals that are recommended. The resources and reserves that are estimated, these are to be in terms of sales quantities, in contrast to produced quantities. Now, fuel, hydrocarbons used to generate energy during operations can be included as reserves under PRMS, but they are accounted for separately so that the user of a report generated by a PRMS evaluator will know that including in overall reserve, say, is fuel consumed in operation, but that amount is broken out separately, even though that fuel is never diverted to sales. And then finally, PRMS allocates net resource on the basis of the entitlement that a given entity has under the contract which governs the resources. Let's look at some key changes to the PRMS document that was issued in 2007. The changes are primarily clarifications. There are a number of minor modifications, but basically this PRMS is an unchanged document. It's just had these minor tweaks. Particularly important are clarifications. And the reason for this is improved clarity and, as we shall see, a bit of enhanced granularity within PRMS. The modified document does have a modified resources classification framework, which we'll look at. It provides an updated project maturity sub-classification system. It provides it provides these project maturity subclasses, and it also recommends that these subclasses be used because they can provide clarity on the maturity of a project, as we'll see as we discuss them a little bit later. I'll note particularly that within contingent resources, there has been a subclass added. Formerly, there were 3 subclasses, and the subclass of resources being on hold and unclarified were part of the same subclass. They have been separated in this update, and this does provide additional granularity. Also, there is clarified movement in this updated document of contingent resources to reserves. All right, here is the updated PRMS framework. Now, at first glance, it looks like the 2007 version, but there are a few tweaks to this, which I'll mention. Let me first give you the broad idea. PRMS is intended to be a system which allows us to inventory the total petroleum initially in place within a petroleum accumulation. And we see that on the vertical axis on the left-hand side of this diagram. All right, that total petroleum initially in place within an accumulation can be divided into undiscovered petroleum initially in place and discovered petroleum initially in place, obviously, and that covers all the resource, that petroleum accumulation. The undiscovered petroleum initially in place is subdivided into prospective resources. That's the part of that undiscovered resource that is believed to be recoverable. And then also, as part of that undiscovered resource, there is a part that is believed to be unrecoverable with today's technology and with perceived economics over the life of a project that might be used to recover the resource. In discovered petroleum initially in place, we have divided this into sub-commercial petroleum and unrecoverable petroleum. So what, again, a significant fraction of any petroleum accumulation is likely to be unrecoverable today, based on what we know today, and contingent resources are that fraction which are believed to be recoverable. But they're not yet reserves because it has not yet been established that they meet our criteria for commerciality. When they do, we at that point have reserves. All right, what's the difference in this framework and in the previous framework? Well, really none yet, but I will note that the classification as to whether it's prospective resources, contingent resources, or reserves, this is based on an accumulation's chance of becoming commercial or its chance of commerciality. And we'll denote this chance of commerciality with the symbol P sub C, and that's the chance of geological discovery, PG, times the chance of development, P sub D, once it has been discovered. The classification is based on this chance of commerciality. And so these explicit chances have been introduced. One clear-cut difference is that within the updated PRMS, you'll notice in prospective resources that we have the categories of 1U, 2U, and PU. 1U is high confidence, lower probability chance of recovery. 2U is the the middle case, best estimate of recovery, and 3U is an upside case of recovery. You'll notice probabilities associated with these for use with probabilistic methodology. But probabilistic methodology or not, these are our low, best, and high cases. In contingent resources, this continues the former nomenclature system. We have 1C, 2C, and 3C, but also now note that we have incremental categories, C1, C2, and C3. Notice that standalone low side contingent resources is 1C, that's equal to C1. The difference begins to arise in 2C, that's the cumulative C1 plus C2, and similarly with C3. With reserves, we have the low, best, and high estimates, and we have the 1P, 2P, and 3P, but also new in the updated PRMS are the incremental categories, P1 proved, P2 probable, and P3 possible. The project maturity subclasses have been expanded, as I indicated earlier in my overview. You'll notice that for reserves, we have 3 subcategories: on production approved for development, justified for development. For contingent resources, this has been subdivided into 4 subclasses. Initially, I'd say that a new discovery would ordinarily be subclassified as contingent with development unclarified. It might be placed on hold for a while, but it might not be. This is a separate subclass. And if in gathering information and appraising this accumulation, we might eventually find that we move up to development pending. And then once that the resource has met all the criteria for commerciality, and it's reasonably expected that these criteria will be met, especially including approval by management to proceed to implement the project. We have the subclass justified for development. The major criteria for these various commerciality criteria is they're reasonably expected to be satisfied. Once it's clear that they have been satisfied and management is ready to make a final investment decision, the subclass moves up in chance of commerciality to approve for development. Notice that on this diagram, and it was also true in the previous diagram, that this vertical arrow indicating increased chance of commerciality, it terminates at the approved for development subcategory. In other words, when a project is justified for development, the resource can be considered to be reserves based on the reasonable expectation of development, but there still remains some uncertainty. Things still could change. Once the final investment decision has been reached, presumably there's no longer uncertainty. Yes, I know things can change, but still it is believed by all that the project will proceed, and it has been approved, and the money has been made available. All right, let's look at some specific changes from the 2007 to the 2018 PRMS. The first item that I've noted here is that the definition of contingent resources has been clarified. Quoting PRMS, contingent resources may include projects where commercial recovery is dependent on technology under development or where evaluation of the accumulation is insufficient to clearly assess commerciality. Now, reserves can be assigned only where recovery depends on established technology. Notice the difference. Contingent resources may include projects which are dependent on technology under development. Next, I note that recoverable quantities reported are those associated with development projects that meet economic hurdles, assuming that all non-economic contingencies will be resolved. This is the unrisked commercial success case distribution, along with the estimated chance that the project will be commercially developed. And distribution of these recoverable quantities, these can be derived using either deterministic or probabilistic methods. Continuing with our changes in PRMS, the modernized version has clarified the incremental methodology of placing resources into categories and the scenario method. And I indicated on the PRMS framework, the incremental quantities in the case of reserves, P1, P2, P3, and the scenario or cumulative approach, and the nomenclature there was 1P, 2P, 3P, and that carried on down into contingent resources and to some extent into prospective resources. Another important clarification really is PRMS prohibits use of split conditions in resources classification. This was always there, but this is a clarification. And this requires a single set of defined conditions in a given category. Now, what does this mean? Well, for example, in the case of reserves, PRMS does not allow us to use a different commercial criterion for proved reserves as for, say, probable and certainly for possible reserves. The commercial criteria are the same for resources in any category within that classification. Let's contrast this with a common situation that the SEC has been allowing in recent years, and that is that proved reserves must meet the SEC's 5-year guideline or 5-year requirement, whereas probable reserves could be allowed longer time. That is a split condition. I know there's a tendency of some to say the economic requirement can be relaxed when we go from proved reserves to probable or possible reserves. Well, that's not so in PRMS, and I don't think it's all that likely to be approved in SEC either. PRMS prohibits split classification of project categories. In other words, you can't have 1C and then also 2P and 3P in a given project. The entire project, the resources have to appear in a single category in that project. In PRMS, there are clarified definitions of economic and commercial production. And a key point is that economic production is an element of achieving commerciality in a project. And then finally, the updated PRMS clarified definitions of economically producible economic limit. And let me provide a bit more detail about these points that I've made on these 2 previous slides. First, and now I'll give you some quotes and lots of words, but I think it's important to see all this complete as PRMS explains it. Let's provide a definition of deterministic incremental method. That's an assessment method based on defining discrete parts of the accumulation that reflect high, moderate, and low confidence regarding the estimates of recoverable quantities under the defined development plan. Then let's look at the deterministic scenario method or cumulative method. This is a method where the evaluator provides 3 deterministic estimates of the quantities to be recovered from the project being applied to the accumulations. And the estimates consider the full range of values for each input parameter based on all the available technical data, but one set is selected that's most appropriate for the corresponding resources confidence category. In other words, one set for high confidence or low estimate, another set for best estimate, and a third set for the high estimate. And then a single outcome of recoverable quantities is derived for each scenario. All right, continuing with our look at changes to PRMS, I think I went the wrong direction, excuse me. More detail on split conditions. Now, split conditions under PRMS, they're simply not allowed. What are split conditions? Different defined conditions such as prices, inflation, and escalation used in the different categories for resources in a given classification. PRMS does not allow split classification, as I said earlier. What is split classification? That's assigning a single project to more than one project maturity subclass. And my example there was assigning 1C resources and in the same project, also 2P and 3P estimates. That's simply not permitted. A single project cannot have quantities classified in both contingent resources and reserves. Now, a single accumulation may be subject to several separate projects at different stages of maturity, and so it can have recoverable quantities in several resource classes, but note that's from separate projects. We can't have split classification in a single project. Important is in the updated PRMS are some definitions of economic and commercial, economic production and commercial production. And so PRMS now says a project is economic when it has a positive undiscounted cumulative cash flow from the effective date of the evaluation. And we are to use best estimate recoverable quantities of a project or the low case for more conservative evaluations that meet the minimum evaluation criteria, which might be, for example, a net present value of the project greater than or equal to 0. And our best estimate is based on recoverable quantities up to the economic limit cutoff, which PRMS spells out as the point at which we reach maximum cumulative net cash flow. So that's our definition of economic. A project is commercial when the entity has developed full intent to proceed with development based on satisfying internal decision criteria, for example, rate of return at or above the internal hurdle rate, and there's several other technical and commercial contingencies, and these must be overcome. Now, please note that commerciality is determined for the project and not for the individual reserves categories of the project. In other words, reemphasizing that we have to avoid split conditions. I said that evaluation and the economic limit is based on cumulative net cash flow. Yes, the economic limit is based on that. The evaluation overall is. And we show here an entity's net cash flow diagram. And this diagram comes from the updated PRMS document. And we show cumulative net cash flow on this document. That's with the red curve on the net cash flow versus time. We also show cost versus time. CapEx and OpEx are spelled out with the different colored bars. And the black line, which appears on the top of this graph, this is cumulative production. All right. What points are to be made from this diagram? Well, this net cash flow diagram is to be generated using forecasted production cost and schedule. It applies to a specific set of defined conditions. These can be the constant case, if that's what the regulator requires, or the audience to which the entity is providing this evaluation. It can be the constant case, or it can be a forecast case, but the diagram really applies only to one specified case. And the entity's net resources, they're defined by the earliest truncation of the technical limit or the license limit, duration of a production sharing contract, for example, or terminated by the economic limit, that point of maximum net cash flow, which we identify at the end of this diagram. Now, an undeveloped project must have an estimated cumulative net cash flow as of a given date. That cumulative net cash flow must exceed the liabilities which are incurred by abandonment costs. let's drill down a bit further and look at the definition of economic limit. The economic limit rate, that's defined as the production rate at the time when the maximum cumulative net cash flow occurs for a project, as illustrated on a previous diagram. And in this evaluation, the operating costs should include only those costs that are incremental to the project for which the economic limit is being calculated. That is, only those cash costs which will actually be eliminated if production from the project ceases. Now, these operating costs, they should include fixed property specific overhead charges if these are actual incremental costs attributable to the project, and any production of property taxes, but for purposes of calculating the economic limit, they should exclude depreciation, ADR cost, and income tax, as well as any overhead that's not required to operate the subject property. And you'll notice that I've provided emphasis here by presenting these final points in larger font than the earlier points. Okay, what is a clarified definition of economic producibility? Economic producibility, now quoting from PRMS, this refers to the situation where the net revenue from an ongoing producing project exceeds the net expenses attributable to a certain entity's interest. And the ADR cost, these are excluded from the determination. Now, this particular point I know has caused some confusion among reviewers, but project is economically producible when the revenue from the ongoing producing process exceeds the net expenses attributable to the interest. And ADR, that's simply not included in an ongoing project. All right, looking further at some changes to PRMS. In the updated document, there's a clarified use of the 2P, the best estimate. Alternatively, the higher confidence estimate, 1P, for project commercial decision criteria. Once a project's been tested and commercial criteria are established, the scenarios, let's say 2P is used, then we can check the low and the high categories for economics to see whether they qualify as reserves also. But the test is ordinarily based on the best estimate. PRMS clarified the justified for development subclass and how it differs from development pending. I covered that briefly in my overview, and we're not going to have time to go back into that again, but it is there. The update clarified discovery criteria, and it clarified the chances of discovery, development, and commerciality, which also I mentioned in my overview. Now, I think this is probably the last clarification point that I'm going to be able to cover in the time we have available, but it is a very important point, and I think it's one that, at least in my conversations with operators, is somewhat misunderstood. A project meets the criteria to be classified as reserves using the best estimate, the 2P forecast case. Let's suppose that's the situation, but the standalone low estimate, the 1P case, is not economic. All right, in this case, what we have is the proved reserves are not economic, but we can, under PRMS, report 2P and 3P reserves. Now, as development proceeds, the low estimate must eventually satisfy the economic criteria and be reported as proved reserves. Now, this is what PRMS allows some entities, either because of internal policy or to satisfy regulatory reporting requirements in the country in which the resource is located, they will defer reclassifying projects from contingent resources to reserves until the low estimate case is also economic, the 1P case. But PRMS allows classification as reserves if 2P is economic. All right, in interest of time, I'm going to have to skip to a summary, and hopefully many in the audience will be able to participate with us in a 2-day discussion where we'll be able to go over additional changes in PRMS, but let me summarize quickly so that we can allow some time for questions. Briefly, what I've said is that the updated PRMS was issued in 2018, the middle of this year. Most of the changes, the clarifications, minor modifications, it's not new material. Now, what I've covered in this lecture is by no means exhaustive. I wasn't able to cover any of my backup slides, but what I did cover, in my judgment, that included many changes with the greatest impact. The second major point I'd make is that PRMS is useful even for entities who file only with the SEC. So just because you in the audience are in the US or file only with SEC, I'll still suggest to you that PRMS is potentially quite useful to you. The resource inventories are based on PRMS classes, and those inventories based on those classes and categories are potentially valuable to all resource owners located anywhere in the world. So with this, I will conclude my formal presentation, leaving some time for questions or comments from those of you in the audience.
Great. Thank you, Dr. Lee. I'll ask our audience members to please submit their questions using the webinar tool, and remind you that later today you will receive a link to a recording of today's webinar. There will be an evaluation form, and you'll have a link to the registration details for Dr. Lee's class on PRMS and SEC reserves and resource regulations, and that will be offered 3 times next year in a public format in both Houston and Dallas, and of course it's available for you to bring in an in-house format as well. Dr. Lee, you talked a little bit about the changes in fuel consumed on lease. How is flaring handled with respect to PRMS?
Well, flaring is not a reserve. It's not a sales quantity, and PRMS doesn't allow for flaring to be included in reporting reserves, even if it were reported separately. It's part of production, but it's not part of reserves.
As with all these new levels of categorization, what's the best way to monitor the maturation of the resources to reserves to production?
Well, that question requires a little bit of a complex answer, but basically, I think the biggest issue probably arises in contingent resources. So we start after discovery with the situation being unclarified. We don't know initially whether we're going to be able to progress toward reserves or whether it's going to have to be ultimately classified as unrecoverable. So as we gather more information, we can begin to see how we can progress. And this is a decision to be made by the individual entity that's assessing its resource. At first, we may say, well, based on what we've seen thus far in this unclarified situation, it looks like it's worth doing something with. Now, we can't do anything right now, and so let's say that this subclass is on hold. It shouldn't stay there long. And then as we look at the situation, we say, okay, it does look good. Let's proceed to gather more information. Well, if we're gathering more information and that information looks like it is going to be possible to implement an existing technology, and the economics are likely to be attractive, and we can satisfy the other criteria, then we can progress upward. That is a decision to be made by the evaluator when we've made that progress. On the other hand, if things don't look good, we would go ultimately to unrecoverable. But it's a decision to be made by the evaluator based on the evidence available at the time of the evaluation.
So, in addition to the class that you offer, we've seen some articles in the literature about the updates to the PRMS. There certainly has been an extended process in reviewing it and taking input. What's going to happen next? Will there be other conferences and opportunities for users to learn about the new update?
Yes, that's a very important question that has been asked here. The PRMS update, that's out. It's in the public. What's going to happen to it is that typos, just the usual errors that occur in a new document, they're going to be fixed, and there will be periodic updates, perhaps quarterly, or at least on an as-needed basis. But that's not really the thrust of your question. The big effort that's underway now is to first provide some supplementary documents, and these will include examples of application of PRMS. And, I recognize that even in the material that I talked about today, it's still pretty abstract. And we always ask the question, but how does this apply to my particular situation? Well, the examples document, which will be made available by SPE and the sister societies, this will be posted online. And I think almost sure that will be an evergreen document with examples being added as the need arises, as the need for clarification arises. So that will appear. There will be an update eventually to the guidelines for application of PRMS. There is in existence now. I think I'm correct in saying it was a 2011 document, which provided guidance. That will be updated, consistent. And then finally, and very importantly, the Oil and Gas Reserves Committee envisions a great deal of training to be offered around the world in the updated PRMS. This training varying from 1 or 2 day courses on site with live lecturers where there's a critical mass of people that can be gathered, but also much expanded training over the web. And there will be luncheon talks, brief 1 hour explanations of some important aspects, maybe similar to what I've done here today, maybe emphasizing other important aspects of PRMS, but there will be a very deliberate effort to try to explain the updated PRMS worldwide. And in some cases, economics say it has to be over the web, and others, it will be with a live lecture.
Very good. Well, I think that takes care of the questions that we have today, and we're at our allotted time. So I'd like to thank you, Dr. Lee. I'd like to thank our listeners. And again, remember, you will receive a link to registration details for Dr. Lee's class, and we look forward to seeing that soon. Thanks. Goodbye.
Goodbye.